4.1 Quadratic Functions and Transformations. This is a lot parallel to what we already did with absolute value graphs and linear equation graphs, but except now we're dealing with that x squared concept being a parabola. Okay, your vertex here is still 0, 0. Axis of symmetry, there's nothing different from absolute values. So this is really kind of the same stuff as opposed to just the function itself. So we have graphing translations from, again, your parent function of f of x equals x squared. X squared minus 5, how does that affect the graph? Okay, because it's outside the parentheses, that's going to move it down 5 spots. So again, we're at 0, 0 is my vertex. My vertex here now would be 0, 5. Sorry, negative 5. So go down to 5, put a dot. Okay, there's your vertex. Then your next 2 points of symmetry, and again, you could do this on your calculator, just in your y equals f of x, or I'm sorry, y equals x menu, and then graph it, and you can use your table to find those points, and you just sketch your graph. Here's your new graph. Should use a different color. Okay, now, what's different here? Well, again, look, it's inside parentheses. So vertex, we always talk about inside parentheses, its opposite is positive 4, nothing outside the parentheses, so it's 0. So what does that do? Well, it moves it over 4, so 4 zeros right there. There's your vertex. Okay. Now, again, plug in your calculator to get these next 2 points. Now you could plug in the numbers 5 into your equation and see what you get, and that will give you your y, but work smarter, not harder, right? It's always a rule. If you remember with absolute values, our vertex form, or our standard form of our equation, would be y equals a, and then it's x minus h. Because it's a quadratic, it's squared instead of the absolute value, minus k, where your vertex was h, k. Axis of symmetry was x equals h, and so on and so forth. So, as you're going through this, and we're interpreting this equation here, well, what does that mean? Well, my vertex, I'm going to look inside the parentheses, opposite in parentheses, so positive 4. What it is outside, negative 2. There's my vertex. Axis of symmetry. Okay, it's x equals h. Well, my h is 4, so my axis is x equals 4. To talk about a max or min value, if you look at the first number, see how the first number is positive? Since my a in this case is 3, since a is 3, it opens upwards. So that negative 2 point is a minimum. If it would have opened down, the negative 2 would have been a maximum. But because it opens upwards, it's a minimum. My domain is all real numbers because I can plug anything into there. And there's no restrictions on what I can plug in. What about my range? My range is not all real numbers. Why? Because negative 2 is a minimum value. Since that's the smallest it can be, my range has to be bigger than or equal to negative 2, because that's the smallest, minimum being smallest.